Hey, my name's Nick. I'm a PhD in molecular medicine, and today I'd like to discuss why I think that this rage over pentadecanoic acid or C15 is really overblown. There's a new paper, a relatively new paper, that released on the evidence on its effects on a cellular process called ferroptosis, which is a type of cell death. And the author essentially states that C15 can help fight off ferroptosis. But after going through the article itself, going through the review itself, I'd like to just present to you why I think that's utter nonsense. So, if you'll hear me out, let's go ahead and discuss a little bit on ferroptosis, just so you have a little bit of background on this, so you at least understand to a degree. So, we're not going to go through each one of these different sections, but what I'd like to bring your attention to is this cell membrane. So, this is the external section of the cell. This is the internal section of the cell. This is called the cytosol. We don't see mitochondria in here. We see a bunch of proteins, different iron structures that are interacting with one another. Again, you don't need to worry about that. All you need to really focus on right now is that there's this exterior section, this internal section of the cell. And then there's this protein, which is called an antiporter. So the reason why it's called the antiporter is because while it intakes cysteine over here, it effluxes glutamate. So for molecules of glutamate get ejected, and cysteine then is allowed into the cell. And that's why I wanted to create this distinction of the external and internal section of the cell. So this antiporter, this transporter essentially, is called system XC, and it's what's known as a heterodimer, meaning that you have two different proteins that come together to form this overall protein structure, this antiporter. Now, what's important here is that cysteine comes in and ultimately creates glutathione. Now, glutathione is then used by this glutathione peroxidase, this protein, to then fix or reduce the amount of reactive oxygen species, so these damaging molecules that are found within the cell. So that's really the main point that I'm trying to get across here. Now, if something were to happen to system XC, that would mean that you'd have less cysteine, which would then have these trickle-down effects where you'd have less glutathione, and then you'd have less ability for this glutathione peroxidase enzyme to then be able to eliminate these damaging molecules that are produced within our cells. And these damaging molecules, they actually accumulate specifically in our mitochondria. So you can see that if you have more of these damaging molecules, then you'd be affecting the mitochondria, which is how ferroptosis functions. There's also an iron related component that I won't really be going into, but the main point being that the fragility syndrome that's been presented in this paper over here, if I can quick bring this up, this is the paper that I'm talking about here. This is the relatively new one that released, where they talk about a fragility syndrome that occurs with cells. And one of the components, as I understand it, is that you have greater production of ferroptosis, or death of the cells, which how that relates to mitochondria is, if we can scroll down here real quick. Yeah, they've got a diagram here of what this would look like. You have these fragile fatty acids in the cellular membrane, which is this membrane that I talked about here, right here. And those then enter, or those then affect the function of the system XC, so that cysteine can no longer enter the cell, and which ultimately leads to lipid peroxidation, which means the damaging of the lipids, not just in the cell membrane, but also in the mitochondrion, because the mitochondrion has a membrane, actually two membranes, and these lipids are also integrated into the mitochondrion. So if you do damage to those lipids, then to those fats, which is the same thing as a lipid, in case you weren't aware, then you end up having a slow destruction of the mitochondria. And of course, you can imagine that if you're destroying your mitochondria, the cell is not going to be living for much longer, which ultimately leads to cell death through this specific mechanism of ferroptosis. Now, as I mentioned, there's also a component with intracellular iron, but the main effect that these fragile fatty acids or these fragile fats would have is on the membrane. Now, to be clear, however, this is what's been proposed, but there's actually no evidence here for that. And that's kind of what I'm trying to get across here, that there's this, this robust review. They release this review and they say, oh, it does this and it does that. The C15 does all these different things. And then they provide very little evidence for that actually being the case. And to illustrate that, let me go ahead and jump to the ferroptosis section. So real quick right here, they said that the core argument of the cellular stability hypothesis that C15 deficiencies cause ferroptosis and accelerate the onset of downstream aging-related diseases. So to illustrate what I was talking about in terms of providing no evidence, here's kind of their punchline statement. Further, when red blood cell membrane C15 concentrations are near or below 0.2% of total fatty acids, the result is ferroptosis. Now, if you're looking for a reference here, it doesn't exist. And that's because, as far as I could tell, they don't have any evidence for that. In addition, I'd like to point out that red blood cells, of all the cells in our body, red blood cells are the only ones that don't have mitochondria. So here we are, we're looking at a condition, ferroptosis, that occurs through mitochondria, and yet the cells that are being used to assess if ferroptosis occurs don't have mitochondria. So anyway, I just like to point that out first, and then we can go on to some other components. Okay, now in this section, they talk about the direct evidence that C15 has in relation to ferroptosis. So they talk about some associative data, but that's not how you assess ferroptosis. I can tell you that because I've done some of these cellular assays myself. But here they're looking at the direct evidence. So you would expect, if you're doing this correctly, that you would do some sort of experiment where you apply C15 to cells that are undergoing or prone to undergo ferroptosis, and then you would see if they have a lowered propensity, a decreased propensity to undergo ferroptosis. So you would apply C15 to the cells, and then you would apply a ferroptosis-inducing drug, which we actually went over. I didn't actually point this out, but you have ferroptosis inducers that you can apply to the cells, and then you would have a control condition, and then you would compare between those two to see if the C15 actually protects the cells from ferroptosis. That's a really simple experiment. I think it would probably take about 2 weeks to do many iterations of that experiment. So not extremely difficult. Now, if you want to do it in different cell lines, you could do that too. So in total, it maybe take you a few months. Now, on the other hand, the evidence that they do provide, which, because to be clear, they have not done that experiment, which is super simple. What they have done is done these like quasi jumps through different studies that don't directly look at C15 and say, oh, here's the evidence for how C15 affects ferroptosis. So in this example, study 50 here, they look at a mouse model of non-alcoholic steatosis, or looking at fatty liver disease or a form of fatty liver disease. And they say C15 treated individuals. These aren't individuals, they are mice. just to be clear. And they actually did not apply C15. What they're referencing is this paper right here, where they actually applied dietary inulin, which is a fiber, to the mice. And these mice have particular microbes in their intestinal system that allows them to convert this inulin into C15. Now, to be 100% fair, these researchers also tried applying C15 directly to the mice and did see some changes in some of these like gene signatures and things of that nature. But to be clear, again, is that looking at gene signatures and even looking at molecules in general is just pales in comparison to the actual clinical evidence that you would need to be able to say, oh, C15 helps with this and that different outcome. So this is really poor evidence. One, the study is looking at dietary fiber or a particular type of fiber. It's not looking at C15 directly, not until later in the study. And even when it does, it's just not looking at really important outcomes on actual overall outcomes like heart disease, fatty liver disease, things like that. They're looking at gene signatures within fatty liver disease. And the other thing also is that they're not looking at ferroptosis at all, not one bit. So to use this as a piece of evidence in favor of C15 affecting ferroptosis is just not, it doesn't make any sense. The other thing here, they cite number 47 here. So number 47 is a study that I actually read before, which is from this group themselves. So the researcher, the person who authored this article is also the same person who authored this study 47, which there's nothing wrong with that inherently. But if you look at the way that they do the experiment, they're looking at the reactive oxygen species generation of mitochondria. And it is true that if you look at their values at the 20 micromolar level, that there is a drop in the reactive oxygen species generation. However, that drop is not exactly massive. It's a relatively modest drop in reactive oxygen species generation. Not to mention, this is a small gripe on my end, but if you look at the vertical axis for this graph, as a matter of fact, let me just quick show it to you. Yeah, so this is what I'm talking about. It comes from this study right here. And it's by the same author, just so you're aware. And if we look down here, they're referring to this evidence right here, which is in a single cell line. And it's in a stress situation. So they're specifically applying a stressor to the cell system, which is fine. That's perfectly understandable. And they're actually comparing the C15 addition to non-treated controls, which is a subpar way of going about these kinds of experiments. Typically, you would want to do what's known as a vehicle control, not a non-treated control. And in addition to that, although it is true that the reactive oxygen species generation was lower at 20 micromolar of C15, which is exactly what they say in the review, the other thing here is that the overall change is really not that great. So you're talking maybe from like, let's say 12 or something like that. And the control condition had maybe 22, 23, whatever this percent reactive oxygen species generation. So you may be talking about a 10% drop, something like that. Now, there are far more potent systems out there, far more potent molecules out there that reduce reactive oxygen species generation by a considerable amount more than what we're seeing here. And in addition, I quick got distracted, but this is a small gripe on my end, but they also misspelled mitochondrial. They misspelled it mitochondrial. Anyway, that's it's kind of beside the point. And then they go on to talk about looking at the threshold amounts for stabilizing red blood cells to alleviate anemia in dolphins. So none of this, absolutely none of this, is evidence that C15 affects ferroptosis through this mechanism that this whole review is based on. The evidence of ferroptosis and aging-associated diseases with this C15. I mean, you're making all these claims, yet you're providing no evidence. Now, if that's a hypothesis, that's perfectly fine. But to be honest with you, with considering that this person is one of the co-owners of Fatty 15, which is one of the companies, probably the primary company at the moment that produces or sells C15, it's a little hard for me to believe that they're just going to go about this by saying, well, this is just our thought process, that it might work through ferroptosis, because they have this whole paper designed to get people excited about this mechanism when they provide absolutely no direct evidence that C15 actually affects ferroptosis. Anyway, I thought I'd get on here. Hopefully that was somewhat clear. Now, there's certainly more that's in the paper. They reiterate some points about the association with some of the dolphin research, as well as some of the other research that they've done. And to be fair, there have been other studies looking at C15. There have been a few clinical studies, and I've covered those before on the main channel. However, the evidence from those studies is pretty lackluster, as in it might have an effect on fatty liver disease. It may have a very small effect, to be clear, kind of a modest effect on fatty liver disease. But in a lot of other metrics, it completely falls short, as in it doesn't show any sort of benefit. So my problem with this kind of stuff is that, unfortunately, with a review like this, people are going to read it and think, oh, well, they figured out the mechanism by which C15 does this, when in reality, no, they haven't. They haven't shown any evidence for that. But on top of that, they also say that it has to do with the fragility of the cell membrane, when in reality, they haven't shown any evidence in relation to C15 being in the cell membrane as it relates to ferroptosis. They have shown, or they've at least talked about it being in the red blood cell membrane. But as I explained, red blood cells don't have mitochondria. So we can't do a proxy of, oh, it's in the red blood cell membrane, so possibly it might be affecting mitochondria somewhere else. It's just, you start getting into this really weird space where you're trying to leapfrog from one tiny piece of evidence and trying to make a link to another piece of tiny evidence, when in reality, the experiments are super simple to do. They would take a very short period of time. And all you would have to do is just, again, apply C15 to the media, to the liquid containing the cells. And you could do this across a number of different cell systems. Apply a ferroptosis inducer to actually induce ferroptosis. And you would also have a control condition that you could then compare against. And hopefully, in this case, it would be a vehicle control, not a non-treated control. So then you'd be able to quantify if C15 actually directly has an effect on ferroptosis. So writing an entire review about how C15 works through ferroptosis to improve all these different health outcomes, when it wasn't even tried to try to assess this, is completely beyond me, to be honest. Anyway, I think it's a lot of hype. I think that C15 could still have some potential benefits. I think that, but considering the hype is so freaking high, and the level of just BS being spewed out there is so strong, like the marketing is so strongly, like the marketing for this will probably be, we have figured out the mechanism by which C15 affects our cells. And yet, as I explained, they provide no actual data. So if somebody opens these studies up and sees it's just fluff that they've put together, at least that's my opinion, and I strongly feel that way. You end up finding out that this is a lot of marketing hype. It really is. So I'm not convinced with the current evidence. That may change with future evidence. Of course, I have to stay open-minded as a scientist, but I remain massively unimpressed. I'll leave you with this one last note. If you go on social media, if you go on YouTube, if you go on social media in general, and you look at the C15 videos, the number of people that are talking so glowingly about C15, even when they flash the title of the different studies and whatnot, I'm honestly just blown away by the sheer laziness, or the I don't know what it is, just the lack of wanting to actually do their due diligence and reading the studies themselves to just determine if there's any level of consistency and good data here. And what I've done so far across 8-9 studies is I've determined absolutely not. There is so much bad data related to the C15 product. Anyway, that's my opinion. Let me know your thoughts. Till next time.